Okay, 3, 2, 1, it's jam.
Earth isn't exactly paradise. Nature hits us pretty hard. Sometimes we have disasters and tragedies in the form of geological and hydrometeorological hazards. So it's basically the earth and the oceans messing us up. So here we have a GIF of an earthquake. So it's the shaking of the ground due to released seismic energy. And what causes earthquakes, the energy that it comes from, is from potential energy in the form of seismic energy. So seismic energy builds up due to tectonic movement. Just like a rubber band being pulled, the tectonic movement builds up pressure and energy in faults or fractures in the rock. All right, and because of the sudden movement of this fault line, we get earthquakes. So again, the buildup of energy suddenly turning into kinetic energy is an earthquake. So we have a focus or a hypocenter, which is the actual origin of an earthquake, and the epicenter, which is the point on the surface right above the focus, right? So where do they happen? Where does the energy build up? So again, they build up in faults, any break or fracture in large masses of rock, and they're common at plate boundaries. So we have plate boundaries that have normal faults, reverse faults, transverse faults, things that we have discussed in previous videos, right? So your plate boundaries, it's where the rock keeps rubbing on each other. This is a map of the earthquakes that are logged around the world, but it's an old map, and it also gives us a good idea of the plate boundaries. So we have the Philippine plate there, the Pacific plate here, but there's also earthquakes in the middle of these plates, but they're very, very rare. So again, it's not just at plate boundaries, we also have earthquakes in the middle of plates. We call them intraplate earthquakes. So they happen at faults where the plate is getting stretched, so the actual plate itself might even break apart. And the plate can also have an earthquake if it's near volcanoes. So those volcanoes can occur because of certain okay, sorry, scratch that. We're going to talk about that later. So earthquakes are measured using two different types of measurement. So we have the magnitude and the intensity. Magnitude just measures the actual energy released. So that's what's reported in the news. The Richter scale measurement, the magnitude. And intensity, on the other hand, is the relative effects of the earthquake, meaning how much damage it does. It's measured usually, using a Mercalli intensity scale. So why are earthquakes dangerous if it's just shaking ground? It's not just shaking ground. There's actually lots of different hazards. So we have ground shaking, of course. We have tsunamis that can occur on coastlines. We have ground displacement or landslides or mass wasting. And we have liquefaction. This one's special. It's basically when the sediments, the loose particles underneath heavy things, get shaken loose. So when they get shaken loose, the heavy things on top of them start to sink into the ground, like this poor building here. Alright, so there's many hazards that are related to an earthquake. It's not just shaking. So aside from earthquakes, what else does the geosphere affect us with? So we also have volcanic eruptions. It's the release of steam and lava from a rupture in the crust. So these eruptions are caused by energy coming from, of course, the Earth's interior. It's the buildup of magma. So it's usually, again, due to tectonic movement. You guys saw this in the seafloor spreading videos, that in subduction zones, the oceanic plate or oceanic crust gets partially melted into new magma that goes up and out of a volcano. But there are other places, not just at subduction zones. So we also have hotspot volcanoes. You might be familiar with this from last year. So they are from mantle plumes rising from the core. So from the core, convection and radiation suddenly have an upwelling of very hot, energetic magma just rising up and then breaking out of the crust. Yamete! No! Dame! Yamete kudasai! And then it just comes out as a hotspot volcano. Alright? So why are they dangerous? Aside, they're just letting stuff out. You know, how is that a bad thing? So aside from letting stuff out, the lava flow, there's also, of course, other hazards, just like in earthquakes. Tephra is the volcanic material, so that's both ash and the volcanic bombs. The ash or the tephra is basically what causes ashfall. You know, it changes climates, it pollutes things. Volcanic bombs, on the other hand, are large pieces of volcanic rock with molten lava inside of them. So when they hit the ground and they break apart, lava splatters around and then burns everything. So it's extremely dangerous. Lahar flow is basically a mud flow from ash and tephra. So it's hot, it's thick, it's messy, it's not fun. Your volcanic earthquake, on the other hand, so your volcanoes can also cause earthquakes due to the magmatic activity and the changes in pressure underneath the ground. So, more fun. And it's not just the geosphere. As we mentioned earlier, there's hydrometeorological hazards, meaning from the ocean and the seas and weather. So, of course, the most common example are cyclones. They're rotating masses of air with strong spiraling winds. Here in the Philippines, we call them typhoons. So why are there many different names? So the different names, typhoon, hurricane, cyclones, these are named after the different places that they form. Hurricanes form somewhere in the west, typhoons somewhere in the east, and cyclones down south. All right, so it's just depending on where they are forming. Next, what causes typhoons? What causes different types of cyclones? Where does the energy come from? So we hear the term low pressure area in the Weather Channel. So a low pressure area is a place that has, of course, less pressure, and wind or air tends to move towards low pressure areas. Now, when there's a cold mass of air and a warm mass of air that go to a low pressure area, it can create rotation. And the rotation in the low pressure area causes water and clouds and many types of forms of energy and water and air to coalesce into a storm. So generally it forms at low pressure areas where there's a cold front and a warm front of air. So typhoons form, where do they form? Like what actual specific locations are most common? We have the intertropical convergence zone. It's where the northeast trade winds and the southeast trade winds meet together. It's the ideal conditions for storm formations. It's not too violent, the winds. There's periodic warm and cold air meeting each other, and the ITCZ is precisely where the Philippines is. That's why we get lots of typhoons. Fun, right? So why are they dangerous if they're just wind and rain? It's not just wind and rain. We have storm surge. It's a sudden rise in water level because of the water that's being poured by the storm and also taken in by the low pressure area. So the oceans and seas themselves, sometimes even rivers and lakes, the water level gets modified by the low pressure area itself. And a special type of tide also occurs during storms. We have what we call riptide currents. So they're narrow, strong currents from sandbars being suddenly destroyed by the weight of the water inside the sandbars. So the sandbars form specifically because of the waves brought by storms coming in from the ocean. So riptides can actually pull you farther out to sea very, very suddenly. And a special type of formation that occurs with some very strong storms are tornadoes, or ipo-ipo in our native language. So they're more frequent though in North America. We don't see this very often or very strongly here. So they form from cool downwards air and warm upwards air, turning into a net rotation. And if that net rotation becomes heavy and strong enough, it can touch the ground. And that's called a tornado. And there's more, as usual. We have also the monsoon. So in the Philippines, we call the monsoon seasons habagat and amihan. Habagat, coming in from the southwest, is what brings heavy, humid weather, and it usually happens from June to October. Your amihan, on the other hand, amihan monsoon, is trade winds coming from the northeast or the eastern part of the Philippines, and that usually brings colder, drier weather, and that's usually during November all the way until March. So that's what gives us the Christmas atmosphere, the amihan monsoon. So there's a lot of hazards. They can come from the geosphere, the atmosphere, and the hydrosphere, but the biggest hazard of all, guess, it's humans. We tend to hurt ourselves the most, more than what the earth throws at us. It's us that really hurts ourselves. And in a way, some scientific studies have already seen indirect effects of human activity on more extreme natural hazards. So we're bringing a lot of it on ourselves. So what can we do in order to minimize the hazards to ourselves? World peace, stuff like that. questions that are very, very big to tackle and might tackle in another video. So I'll see you guys next time. Thank you for joining me, and I'll be back.
Party's over.